Okay, good day, everyone. So, yeah, before we start the presentation, like Leno said, we have been, at Procter & Gamble, we have been using Bayesian Belief Network, or in general, probabilistic graphic model a lot across different business unit. So we are actually right now actively hiring Bayesian engineer or Bayesian scientist. Either you are a statistician or engineer. If you are interested in exploring new opportunity, please go to pg.com career and type in Bayesian. You will find the position. Thanks. A little bit of advertisement. So today, we used like a BBN in a lot of the projects, but a lot of the project, unfortunately, we cannot get approved to present here. So after my former colleague and friend Michael Thompson retired, we really in urgent need of finding more Bayesian engineer and scientist in the company, as the hiring I said earlier. I do have one colleague today, Ji Qing, joined me in the audience. So in the future, he will be also, I assume, active attender and presenter in this conference. So today, I wanted to talk on one project we are working on. We try to use BBN model to identify consumer persona in high dimensional parameter space, really high dimensional parameter space. So a little bit background. Let me minimize this maybe. Yeah, so this is a project regarding a digital app. It's called Setlist Beauty. Setlist Beauty is the app owned by P&G. It fulfilled the consumer desire for a digital beauty app, learning how to categorize consumers interested in a digital app concept and provides data for guiding the next steps needed for our brands, for different brands. That's the purpose of this project, persona analysis. So how we essentially collect the data for the app users. We also collect some data from prospective users, meaning they are not the users yet. We launch a survey to collect the data, from both prospective users and the current users. Go to next one. Yeah, so this is the introduction. Yeah, I assume you all can hear the sounds, the audio, is that right?
Yes, that's correct.
Okay, that's great. So this is the app right now launched only in Apple Store, only in US, in the US market. We do have plan this year or the coming physical year, roll this out to all the markets other than Greater China. So we apparently from the video, you can see we collect all kinds, not just collecting data. The main purpose is to, to deliver, to solve consumer problems. It's like, if they have skincare concern, if they have hair care concern, how do we help consumers to, let's say, solve the anti-aging issue, solve the acne issue, etc. We do that by, provide a holistic solution, including, let's say, product regimen recommendations, and also how to best use the product. And, most importantly, if they have questions, they can talk with professionals staffed in the app, like, the esthetician, the hairstylist, etc., to get, advice from real human, from real experts. So to develop the app to understand our consumers, we launched this project called persona analysis of the users and the prospective users. Apparently, you need to understand the consumer to, let's say, design different features in the app, or how do you improve the existing features? Most importantly, how do you best serve consumers? These all need to understand consumer deeply. So we collect the data from the app. We also collect the data by launch a survey with the help of one external agency. So we actually early on tried to hire the external agency to do the essentially when we say persona, meaning you segment the consumers, you clustering consumers based on the data, right? So hire the agency to do that. It turns out the quality of the work was not really good enough. So they run some clustering, other than K-mean, I guess they also do all kinds of analysis. But the results was not really, how to say, actionable, really not inside of us. So we decided to do the analysis ourselves. We run some apparently different majority of the methods distance-based like a K-mean or density-based methods like HDBSCAN, DBScan. We also run some Bayesian methods like profile regression. These are the probably latest methods in clustering, and also the PoLCA, Polytomous variable latent class analysis. But the issue is, we have really high dimensional data. We probably have 1,500 consumers. For each of the consumer, we have maybe 500 variables to describe these consumers. So these are really high dimensional data. Majority of the methods like HDBScan, K-mean, user density, or distance-based clustering methods doesn't really work well in the high dimensional space because you have really sparse data points in the high dimensional space. So majority of the methods, they just, let's say, either cannot find the meaningful clusters, or most of the time, just to say 2 clusters. So we tried the Bayesian Belief Network. I will not present results from other methods in this presentation, mainly focus on this Bayesian Belief Network methods we did using BayesiaLab. Of course, you can argue, for high dimensional data, you can always, let's say, use PCA, this need to reduce the dimension. We tried that. The thing is, the performance-wise, it didn't really improve that much. Most importantly, we do want to have the granularity understanding at the individual variable level. So apparently I need to anonymize the data or even fake some of the data because of the protecting PNG's interest. So each of the node is one variable. It's called DQ, meaning direct question. Either collected from survey or collected from the app. So by running clustering analysis as the data clustering in BayesiaLab, if you don't know, just Google it. It's really easy to do. So in this case, specific case, we just run, it's a naive-based model plus med clustering. Med clustering meaning after you run naive base to do clustering, you run another clustering on the clustering result you got. It's called med clustering. I mean, in reality, when you operate this in BayesiaLab, you just check some box that will get the med clustering part done. So the purpose we use med clustering is to get a stable solution. So, I think, BayesiaLab put a lot of a great document on the website regarding the clustering. For this clustering, we wanted to get, distinctive clusters, meaning between clusters, you wanted to have distinctive separations. That's the bottom part this figure shows. the distance among them. And within each of the cluster, you wanted to have homogeneity. You wanted to have the purity measured by purity. So this is one example. We run run this specific example is on both prospective users and setlist users. We also run clustering apparently on prospective users alone and also setlist users alone. But for this specific example, is on both users. The pink note here, later on, it will be clear. We can, according to the clustering results, there's a metric to decide, which variable is relatively important to differentiate the clusters. So the pink notes are the important questions which can help us differentiate different clusters. So these are the top 20 most important questions according to the model. These top 20 questions can help a lot dominate the way to differentiate consumers into different clusters. So when we say top 20, meaning it is measured by relative significance. If you run BayesiaLab, you will know from the table generated from the data clustering, there's one column metric called relative significance. So that's the pink nodes, when you see, you can use relative significance, right? And then I'm going to go through, maybe two segments, segment 1, segment 5, actually 3 segments. Segment 1, segment 5, and segment 2 as example, how do we leverage the results from here. So this is one table, actually part of the table generated by BayesiaLab. By running data clustering. So these are the nodes. Apparently, you can, if we don't anonymize this is essentially a direct question, right? You can have a intuitive question here. So this is relative significance I mentioned earlier, but the earlier plot is for the overall population for all the clusters. So these are the, you can think of, importance of the variables for this specific segment, for the first segment, right? So to read the column, you can find the relative significance here. And then most important, the information here, we will detail later. I do keep one example here. Let's say, you have some intuitive understanding of the results. So this column is like the answer. This is the answer, categorical answer to this question, right? I just use a number here for, again, protecting our interest. So for example, this one, planning neutral is the answer to this question, consumer answered, right? So this column meaning a lot of consumers in this segment, their dominant answer to this question is this one. So on the mean base factor on this column are the consumers. We just have a few consumers answer 5 to this question in this cluster, as of course compared to the overall population. So essentially, you can think of here, the answers consumer give to this question are overrepresented in this segment as compared to the overall population. So you can also see the percentage, how many people in this cluster give this specific answer to this question. So this is the base factor to characterize the answer, the significance. If you use a frequentist way to measure that, essentially measure how this consumer, if they answer this way, right? How their answer agree with this segment, the tendency falling into this segment, right? So the base factor here is the unit is a bit, meaning it is a log 2. The base is log 2. So if it is above 1, if it is above 1.6, meaning it is substantially favor the segment. If it is above like a 3.3, it meaning strongly favor this segment. So I know the information here is really dense. It's kind of, a lot of great information here. It's hard to digest in one table. So I wrote a script to visualize the information. So this is essentially part of the information you saw from the earlier table. From here, these are the percentage. This is the maximum column we talked earlier. We say, these are the overrepresented in this cluster in segment 1. Again, these are the bar, the length of the bar represent the percentage of the consumers in this cluster, give this answer to this question. So the star, single star, meaning substantially favor this segment according to the base factor, and a double star, meaning strongly favor this segment according, again, to the base factor. Imagine if I don't anonymize the data, you can see the question here, you can see the answers here. If this is shown on the website, it's more intuitive, I would say. I mean, this could be in the future, another request from P&G to make a plot like this from the table. That will make it really easy for, let's say, product researcher or practitioner to interpret the clustering results. So furthermore, this is another like a feature in BayesiaLab right now. You can do that easily. It's called profile. When you go to analysis segment and the profile, you use the cluster, the segmentation variable as the breakout. You will be able to see, let's say, the profile of your segment 1 and their difference from the overall population. That's the red curve. Apparently DQ, the variable 309, is really a good differentiator. Differentiates segment 1 from the overall population. Again, these are the light blue, meaning the statistic significance using frequency t-test. The dark blue meaning the Bayesian test. So we call that practically meaningful. It is significant according to Bayesian test, and we call that statistically significant if it is satisfies the t-test. So this is another comparison of, let's say, segments 1 and segment 2, right? You can see they are quite different essentially. And the most important, you see the significance of the comparison, right? The different questions and also the detailed answers they provided. So this is another example for segment 5. If you recall earlier, the DQs and also the bars, the answers, they are quite different from segment 1 we showed earlier. But the way, we read the information is the same thing. Again, I keep 1 here to give some indication how this can be one intuitive tool to interpret the segmentation results. So this is also the profile analysis of segment 5. Recall segment 5 is the largest segment. So that's why it behaves more similar with the overall population, the red one, as compared with segment 1 we see earlier. So before I go to the example, I want to stop here, see, is there any questions? No? Okay. So then, you know, when
we have Arturo who wants to ask a question.
Sure.
Hello, can you hear me?
Yes.
Yes. I just wanted to ask something about the previous slide regarding, you mentioned statistical significance meant was obtained from the T statistic, and I didn't quite get what practically meaningful meant.
Okay, sure. Yeah, that's a great question. So I wrote the original article. So I know this quite well. Without, you know, further help from Leno, I can explain this. So the statistic significance, you see the difference, right, between this guy and this guy, right? So this is a mean value, right? Essentially, you have a group of value for consumer segment 1. Their answers on this DQ307, right? So you have another group of people, the overall population, right? You also have an answer on this one, right? So essentially t-test, use t-test, you can test the difference between two group means. Assume, you know, you used t-test before. That's really easy, yeah. If you do t-test, you get a probability value, right? If the p-value is smaller than, you know, 0.05, it is a statistic significant, right? You simply try to compare, for t-test, you simply compare these two group means, whether they are equal or not, or you know, whether the difference of the group means is equal to 0 or not, right? Yeah, for the dark blue, this is a Bayesian test. There's a paper. If you check, you know, BayesiaLab menu, there's a paper from Krusky. It's called the packaging R is called the BEST. It's a Bayesian test. You can think of, you know, Bayesian t-test, put it simply. So the way it difference, you know, rather than to test whether the difference group mean and difference is equal to 0 or not, is actually try to say whether the difference falling outside an interval or not. It's not just equal to 0 or not, meaning the difference has to be larger than a interval, right? It could be, you know, negatively large or, you know, positively large. You take the absolute value actually. So the term for that is called ROP. It's called the region of practical equivalence. So only when you know, you follow, you know, your difference outside of the region of practical equivalence, and then we say these two groups are different. So you can think of, you know, these are more conservative. That's why you see, you know, some of the variables you have blue circle, but you know, light blue, but you don't have dark blue. But in general, if you have dark blue, you usually have light blue because it is more conservative. That's why we say it is practically meaningful. If you read the paper, that's the way they call the ROP, right? If you say it's a ROP requirement, it is practically meaningful, not just a statistically significant. Let's go to the next two slides. So with the results we got from the clustering, the different answers the tables, the visualizations we got, you know, we can essentially profile segment 2. Imagine, you know, we know there are dominant questions in this segment 2. We also know there are dominant answers to that questions. We can say, you know, what is their age group? What is the income level? What is the education level, employment status, etc. You can have like a pretty good profile for this group of segment 2. Let's say for this segment 2 is anti-aging. Their main concern, they try to, you know, find the anti-aging solution. The magic bullet, apparently I need to, you know, simplify this again, you know, to for our interest. You know, what they want is they wanted to some magic bullet in skincare. The pinpoint apparently, you know, unfortunately here, review our secret is anti-aging, let's say. The reason they are with us is, you know, they are willing to try something to get, you know, meaningful results. We also can derive some insights from the questions, from the answers. You know, they also have some statements. Of course, these are simplified statements, you know. They're willing to do something essentially to look younger. I mean, this, I hope this intuitively makes sense. So you can do this from the results for different segments. And then, the last slide, I believe I have, you can have some actionable insights based on the profile, based on the results. Like, the first row is the proportion of the segments. And also, their, for each of the segments, you can measure their concept appeal, how they, visualize, how they rate your different concepts you proposed as a feature, let's say, as a feature of the app. And, also specifically, what is the appeal to our Setlist app? The consumer job to be done is, like for segment 2 is find the best thing in anti-aging to slow down the look of aging skin. You can also see, because this specific study is for both Setlist users and prospective users, we can also see how many Setlist users are in this segment. And we also see the NPS score. NPS score is like, essentially whether they're recommending the app to others or not. Apparently, we want to have a larger score, right? So we also can measure likelihood to download, etc. Of course, some other rules we didn't present here, like, how do you drive actions for each of the consumer segments? Yes, I think that's what I have. Any final questions?